Hello, folks! Are you in the mood for a little bit of thermodynamics? Then let's make the most of it and take a look at the ideal gas equation. Sounds like a swell idea, right? Then let's go! The ideal gas equation. Doesn't it sound like math? I'm afraid there's also a bit of that too, but it's quite straightforward. It's far more important that you've got an idea what an ideal gas is in the first place. If you're not so sure about that yet, check out our video about ideal gases. If you've already got that covered, then we can start to play with this equation. It looks like this. Let's go through what the whole thing is supposed to mean. P is the pressure, V is the volume, N the amount of substance, Rm the universal gas constant, and T is the temperature. Great! But what can we do with this equation? We also call the ideal gas equation the thermal equation of state. That's also a good name for it, as that is exactly what the equation does. It describes the state of an ideal gas with just a few parameters. Since Rm is a constant, we only need 3 other parameters here and use these to work out the missing 4th parameter, like the temperature, for example. With the pressure, the volume, and the amount of substance, we could find the temperature of an ideal gas. That's already really handy, right? But the ideal gas equation is not just great for figuring out state parameters. It's also really easy to calculate changes in state with it. Check this out. Imagine an ideal gas like this, which we have sealed off with a piston. We push this piston down so that the volume is decreased significantly. The process is isothermal, by the way. That just means that the temperature doesn't change. Let's start with the initial conditions. What are we missing here? Exactly, the temperature. We can figure out the temperature using the ideal gas equation without breaking a sweat, because we already know all other parameters. We have even just rearranged the ideal gas equation for T. Helpful, right? And because the process is isothermal, we know that the temperature in the second state must be the same as in the first. Let's write down the ideal gas equation for the second state and solve for the pressure P2. Once again, we've been given everything we need, and so we can calculate the pressure in the second state. In many cases, individual states are linked by different types of processes, such as the isothermal process in this case. But we also have isobaric for constant pressure and isochoric for constant volume, for example. To round things off, let's take a look at the different forms of the gas equation. We already know the gas equation as a function of the amount of substance, but you can also specify the equation with the mass of the ideal gas. To do that, we have to know that the amount of substance, N, is just the mass divided by the molar mass. If we substitute that into the gas equation, we get this here. Now, we can cancel out the molar mass with this relationship here. The Rs stands for the specific gas constant, so let's put that in. Now, we have the second very well-known form of the gas equation. One little drawback is that the specific gas constant, Rs, is indeed a constant, but it depends on the particular gas. Every gas has its own constant. For example, air has this value. You can get the Rs from tables or calculate it from the relationship between the universal gas constant and the molar mass. Depends on your mood, really. Now, if we divide the equation by the mass, we get a third important form. We also call volume divided by mass the specific volume for simplicity. And that's it. These 3 forms are frequently used in calculations, so it can't hurt to remember them. So what do we need to take away from this? The ideal gas equation, also known as the thermal equation of state, is really handy for calculating individual state parameters for ideal gases. We can also use the equation to analyze different states if we know how the states are linked, whether that's isothermally, isobarically, and so on. Finally, we've introduced 3 different forms of the ideal gas equation. If you want to see the ideal gas equation in action, check out our video where we work through a small exercise. See you soon, folks!